It's a pleasure to be here tonight, and I'm going to talk to you, as promised, about science as a strategy. But first, I'd like to take everyone back to 2008. And remember that back then, this is when Twitter was going through its hockey stick growth. And it was going from about 400,000 tweets per quarter to 100 million tweets per quarter by the end of 2008. Now, I don't know about all of you, but maybe a show of hands, folks whose companies invest in social media strategy, influence measurement. A few of you, right? Well, Twitter excited me a lot at the time because I felt this would be a real way of measuring human attention and influence, because following somebody on Twitter would represent an investment of human attention. You could think of having a lot of followers as like an author with a lot of readers, in particular because Twitter's innovation was that it had an asymmetric model of following. Somebody could follow you without you following them. Super excited. And in fact, people were already saying that you could decide how influential a person or a brand was by counting the number of followers. But it turned out there was a problem with this. And the part of the problem was that actually some of those followers weren't even human beings. They were bots that were algorithmically processing and responding to tweets. But there was actually a more subtle problem, which is that even real human beings, people like us who use Twitter, turned out to use it in ways that didn't quite map to the offline model of human behavior. About 20% of people on Twitter follow over 100 people, and many of those follow thousands. In fact, pop star Lady Gaga follows 140,000 people. Now, I'm sure she loves us all, but it's spreading a little bit thin. So the question was, if you couldn't use follower count to be a measure of influence, then what could you use? Now, luckily, I stumbled into something here, which is a measure that became known as TunkRank. And the idea there was actually similar to the way Google developed PageRank. And the insight was straightforward. It modeled attention scarcity by saying, we have a finite amount of attention, so therefore we have to split it among the people we follow. Therefore, if you follow a lot of people, you're not very valuable as a follower to any one in particular that you follow. And you could thus compute the value of each follower this way and aggregate total influence. And the best part of this, and social media to the rescue, I put this on my blog. One of my readers implemented it. And some researchers in Spain actually found that it outperformed all of the published measures on distinguishing legitimate influencers from spammers. Now, I'm obviously proud of this. It's pretty hard to get in like Tunkelang onto a measure of any kind. But it's actually deeper than that, because what I see in this little TunkRank story is the triumph of the scientific method over gut instinct. I mean, follower count is popular. Even today, there are people still who are counting their followers on Twitter as a notion of influence. But actually, modeling it correctly, thinking about attention scarcity, and then better yet, subjecting that to experimentation and empirical validation, that's what science does. And in fact, it turned out that TunkRank was the way to go. So today, I'm really just here to tell you one thing, which is that science is the difference between instinct and strategy. Now, in a crowd like this, I hope you all believe that already. I mean, we're a bunch of CIOs, CTOs, heads of analytics in our various organizations. But there's a difference between belief and action. And we all know that science isn't always popular in the C-suite. I mean, we claim to have data-driven organizations, but often, all too often, the decisions are made by the hippo, by the highest paid person's opinion. So what I'd like to offer you are 3 concrete suggestions that I hope will help you and your organizations bring science, rationality, data-driven processes into your product and your processes. So the first suggestion is that you have to ask the right questions. I mean, we're all familiar with the phrase garbage in, garbage out applied to computation. But that applies just as much to analytics. We're not going to get the right answers unless we ask the right questions. Now, as it turns out, science is filled with people asking the wrong questions. For example, back in the 19th century, phrenologists were trying to measure intelligence, specifically to look at racial differences in intelligence, by measuring the sizes of people's skulls. The modern-day equivalent might be people in IT trying to measure programmer productivity by number of lines of code. Now, it's easy to identify these things as pseudoscience, and I hope all of you reject them. But sometimes we also ask the wrong questions, and it's important to recognize that and proactively react to it. So let me take an example which hopefully will resonate with all of you, and that's measuring the effectiveness and efficiency of the hiring process. Yeah. Now, LinkedIn, look, talent is our core business, but it's actually also our top priority as an organization. And we do everything in our power to improve its effectiveness and efficiency. So we had this bright idea. The way we do interviewing is probably similar to what many of you do in your organizations, is that we have a battery of interviewers for every candidate. They give their feedback, and ultimately a binary vote, hire or no hire, and we make a decision. So we said, let's measure the accuracy of every interviewer. We would see how well an interviewer's vote predicted the final outcome, and then we would know who the good interviewers are, and we'd be able to train everybody else to be like the good interviewers. Seems like a good idea. In fact, I've worked at other organizations that have tried to use a similar approach. But it's got some problems. The first problem is actually a sample size one. Not everybody does a lot of interviews. But, okay, we filter out the people who haven't done enough interviews. There's a more fundamental problem. You see, it's not majority vote that decides whether we hire a candidate. No votes count more heavily than yes votes. One no vote might be enough to actually reject a candidate. And 2 no votes, they're dead to us. So if you wanted to optimize your accuracy score, you'd probably do pretty well to always vote no. Now, actually, it turns out people aren't trying to optimize their accuracy scores. In fact, they're trying to do everything in their power to do fewer interviews. But that's not the point. We should still measure it at what it is we're trying to improve. And it turns out here, clearly, this is not the right thing to measure. So we went back to the drawing board. We said, what are we trying to do here? We're trying to measure the effectiveness and efficiency of a hiring process. Well, the good news on effectiveness for us is we know we hire good people. And what I mean by that is that we err on the side of losing good people rather than hiring bad people. And we know this because we do enough downstream analysis of productivity, of performance. Nobody's perfect, but we know we're conservative. So it comes back to a question of efficiency. How do we make the hiring process more efficient? Now, there it turns out we have an interesting lever. After we've done the first phone screen, or as we go through the process, we could short circuit. We could say, for example, if somebody bombs the first phone screen, that's it. Or we could go all the way to the end and say, well, we'll do the whole interview process and see what the overall picture looks like. Maybe they had one bad interview. And maybe you can see the trade-off here. If we want to minimize the time spent per candidate, we should short circuit as early as possible. But we want to hire as many good people as possible. And that argues for giving people a chance. And this is a trade-off in terms of the average time per candidate versus the number of candidates that we get through. And you can actually frame this as an optimization problem in terms of maximizing the overall throughput, in terms of the way that you temper the, if you will, how liberal you are early on in the process. Now, that's a bit more of a complex formulation, but that turns out to be the actual question we needed to solve, namely, how do we manage that trade-off? How liberal do we want to be in those initial stages? Let's go back to our initial formulation, which was, who are our best interviewers? I mean, it feels like it might be an interesting question to ask, but it turned out not to be the right one. And it was only by asking the right question that we were actually able to improve the efficiency of our own process. Now, I started by talking about science. You may think that asking the right questions is more of an art than a science. But actually, asking the right questions is the foundation of science. And at LinkedIn, we're known for our world-class team of data scientists. What might be less known is that we don't just look for people with strong analytic capabilities, people who can apply all the techniques of machine learning and statistics. Believe me, we need that. But we also look for people with product sense, with business sense, for people who can ask the right questions. And all of you in your organizations, it's critical to cultivate this practice, this culture of asking the right questions. Because if not, really all the analytics that you have are in vain. Because your analytics are only as good as the questions that you ask. So let me go on to the second suggestion. And that's to practice good data hygiene. Now, look, data mining is amazing. Hopefully, all of you are familiar with some of its fundamental techniques, decision trees, regression analysis. If you're not, happy to hook you up. Because it's really important to actually understand the techniques that the folks in your organizations are using. But let's not forget that data mining was originally a pejorative phrase. It was about data dredging or finding spurious patterns. Because given a quantity of data and given enough time and computational resources, you can find anything. And the most famous example of this is the Super Bowl indicator. Some of you are familiar with this. If the NFL is divided into two leagues, AFC and NFC, and if an AFC wins the Super Bowl, bad year for the stock market. If the NFC wins, good year. And by the way, go Giants, they won this year, and stock market's up. This actually worked with 80% accuracy. Great rule. Okay, so you may think, obviously silly, right? We're just looking retroactively at data. But we make that mistake in more subtle ways elsewhere. So I'd like to take an example that's a bit close to my heart, and that's relevance ranking. Talk about a data-driven area. And you'll have to forgive me. I have some NDAs on this area, so I can't name names. But quick review of the relevance ranking problem, right? We have a search engine. We show results. We'd like the most relevant ones to be at the top, descending order. People are happy. So that's great. The question is, how do you measure relevance? How do you know if your algorithms are working? Well, the most popular approach is to look at what people click. After all, if they click it, it must be relevant. So you do things like maximize the click-through rate, or the click-through rate at 1, or at the top results. And there are lots of variations of this measure. And look, it's not entirely wrong as an approach, but it actually has some major problems with it. And the most fundamental problem is one of data hygiene. You see, we expect as users that what's presented to us is relevant. So we're more likely to click on something at the top. And even more extreme than that, if I can channel Donald Rumsfeld here, we don't know what we don't know. We're only going to be able to click on things that are presented to us. So if there are relevant results that are not presented to us, we can't click on them. So there's a real danger if we only look at click-through rates that we're actually going to have a positive feedback loop confirming the very algorithms that we used to place those results at the top. And this is a fundamental flaw of data hygiene. So what can we do about it? Well, it turns out, and when I say we, I include the folks at LinkedIn, but also at other major companies working in areas that include search, employ a variety of techniques. So one of them is to use human raters. You present results to them in random order, and you ask them, are they relevant or not? And that's pretty expensive. A technique that's a bit more sophisticated is called explore exploits, or multi-armed bandits. And there what you're doing is being more judicious, doing a little bit of randomization so that you're essentially building hypotheses at the same time that you're validating them through clicks. And this was actually used famously by Yahoo to do its homepage optimization. The person who spearheaded that recently joined LinkedIn. But the point being that, and there are lots of these techniques, happy to talk to them after people have had a few more drinks, but you can't mix up data exploration with hypothesis testing. Hypothesis generation has to be a separate step from the testing of those hypotheses. Otherwise, you teach the test. You know, we've all learned this. Correlation is not causality. But you can't hear it enough times. You know, there have been all these arguments about the unreasonable effectiveness of data, the end of theory. But if you don't separate your hypothesis generation from your hypothesis testing, then you're in fact doing exactly what people were talking about when they described data mining pejoratively. You're learning from the past and teaching to the test, and you might as well invest in the stock market based on the results of the Super Bowl. So how do you do this? Well, it's very important that when you come up with hypotheses, you withhold data in order to test them. And many times we're lucky. We generate data quickly enough that we can generate hypotheses based on past data and test it on future data. But that doesn't always work, right? Sometimes we actually do need to test data retroactively. In that case, we have to explicitly withhold data. But we have to do this really zealously, because if we don't, our analysis is infected. So, you know, practice good data hygiene. This is the only way that we can keep ourselves honest as scientists, as people doing analytics. So let's go on to the third suggestion. The third suggestion is don't argue when you can experiment. Now, look, we'd like to think of ourselves as rational creatures, but we're anything but. In fact, Nobel laureate Daniel Kahneman, who actually recently published a best-selling book about slow and fast thinking, has devoted his life to the study of human irrationality. And it actually gets worse. So there has been recent research on human reasoning, and it turns out that reasoning may not even be for the purpose of ascertaining the truth, but rather simply exist as a means of persuading people. So don't trust anybody's theories, not even mine. So then what can you trust? Well, what you can trust are experiments, scientific experiments, in particular controlled experiments, where you can actually see whether a variable is influencing the outcome. Now here, I'd like to turn to a domain that hopefully everybody here has an opinion on, which is user interface design. And I say this because I've been in product review meetings where there are at least as many opinions as there are participants. It turns out also the history of the internet is littered with these arguments over what's the best design. One of my favorite comes from Amazon. So there, Greg Linden, who was the architect of the original personalization approach, had this idea that you should recommend things to people when they were about to check out in the shopping cart. Now, there was an SVP of marketing there. I hope no SVP of marketing in the house, let alone from Amazon, but I'll take my chances. And he was absolutely opposed. He said, look, that's going to distract people. They're checking out, we'll lose conversions. Now, in fact, he ordered Greg Linden not to do any work on the project. Greg wasn't so easily dissuaded, so he ran an A/B test, a bucket test in which he actually exposed some fraction of the population to these recommendations. And it was overwhelmingly positive. And as a result, not only does Amazon, but I think all major retailers today look at shopping cart recommendations as kind of a staple of what they do. In fact, Amazon in general drives 35% of its business through recommendations. Greg Linden now is a famous blogger. No word on what happened to the SVP of marketing. So, look, it's not that the points of view in the argument were unreasonable. You can certainly see why somebody would think that recommendations would be a distraction or that they would drive revenue. But why argue about it when you can run a test like this? In fact, at LinkedIn, it's a cliche that any time you find people arguing, whether it's about interfaces, about relevance approaches, just about any way you could design the site, do an experiment. I mean, not every hypothesis can be resolved by experimenting, but most can be. And sometimes we don't like the results. Last year, we took one of our most prominent marketing campaigns and we did a redesign. we're really excited about it. We put designers on it for a few months, and it was supposed to improve the response rate. Well, actually, it decreased the response rate by a very significant factor. We had to send designers back to the drawing board and run with the old campaign. Not a fun post-mortem, and you can be sure people are like, oh, just give us another chance. But we listened to the data, and we did the right thing there. Unfortunately, most of our experiments have happier endings. If you look at any feature on our site, it's driven first by an A/B test to validate it, whether it's a relevance improvement, the new releases we've had on search or on people you may know, even something as simple as deciding whether to show a picture somewhere or move something from left to right. Often, you can come up with many competing theories about how to do something and just test them all. And the beauty is that if that's the only variable in your test and you can keep everything else independent, you can actually find out and make improvements that way. So, it's a lot of us, we've learned how to argue. We've perhaps achieved our positions by being persuasive. But decisions should not be made by Oxford-style debates when there's an opportunity to make them using data. So whenever possible, do A/B testing. Don't argue when you can experiment. So quick recap, 3 suggestions. Simple enough, right? Ask the right questions, practice good data hygiene, and don't argue when you can experiment. Now, you may be thinking, this is nice and all, but actually data-driven organizations don't always work. In fact, looking, for example, at Google versus Apple, it's a temptation to say, well, Google, data-driven, Apple, inspired leader, Apple won. So perhaps we should just throw our data away and listen to our inspired leaders. Show of hands, listen to inspired CEOs instead of listening to data. Don't worry, the video's only on me, not on you. Well, let's go actually back to 2002. Now, in 2002, Apple faced perhaps the most critical decision in its business history. And back in 2002, the iPod had just come out. It was clearly a breakthrough product for music, but it was only compatible with the Mac. Now, this may be hard to imagine today, but back then, Mac had only a 3.5% market share, and Windows was crushing it, over 95%. Now, Steve Jobs' lieutenants said, look, we could make this a breakthrough success for everyone by making the iPod compatible with Windows. Steve Jobs didn't want to hear it. He said, Windows users will have access to the iPod over his dead body. And so they persisted. And they showed him data, and they were relentless with him. And finally, Steve Jobs couldn't take it anymore. He turns to his lieutenants and he said, I'm sick of listening to you assholes. Go do whatever the hell you want. Fortunately, they did. And that's fortunate for Apple, as well as for all of us who benefited from the products. It isn't easy being one of those assholes. But it's our job, much as it was theirs. Our leaders, however inspired they may be, are fallible. Their instincts, as amazing as they may be, and it's hard to imagine someone having better instincts than Steve Jobs, still are imperfect. It's up to us to provide data, to provide rationality, to bring that to our organizations to ensure that we make the right decisions. Because science is the difference between instinct and strategy. Thank you.
Do we have any questions?
Yes, great talk. Can you talk a little about LinkedIn's future strategy? Where do you see it going next?
Sure. So the question is about LinkedIn's future strategy. So it's clear that we're growing in several dimensions. Right? We already have a notion of professional identity, but we're increasingly creating products to engage people more. Things like, I don't know if folks have seen LinkedIn Today, which is our sort of social news product, so you can see what other people are reading. but also, essentially, what we're trying to do is be the one-stop shop for everything about you professionally. Obviously, things like hiring for folks who engage more outwardly in sales and business development, this is a no-brainer. But also, being able to see things through the lens of the people in your profession, being able to get content directed at you that only we would be able to find for you, because not only we know something about who you are, but we have an aggregate view of people like you in some way. So we really see ourselves as we're going to stay, obviously, in this professional space, but encompassing that much more of your day-to-day professional life.
So do you have any data on the inspiration versus empirical data decisions?
Inspiration versus which?
The data-based decisions, like you mentioned, like Steve Jobs versus all the measurements.
I mean,
do you have
Steve
any
Jobs
data overall on how
yeah.
many times one or the other is right?
So one of the things you have to be careful of with data-driven decision-making is that it's driven by data. You see data afterwards, but we don't have future data at our disposal now. So I think that, and obviously I found an example where Jobs had gotten it wrong. It's pretty hard to find those, which speaks volumes to his track record that clearly beats the odds normally. I don't know how you would assemble data on instinct per se. I think the flip side is that if you actually use data to validate your decisions, you know that you've won. If you go on instinct, the biggest danger that you have is that it's not refutable. When you fail, you'll say, oh, something's just around the corner. There's no hypothesis to invalidate so that you never actually fail. So you don't generate that sort of data. Beyond that, I mean, of course, I could come up with companies that have succeeded going as far back as the 50s by taking data-driven approaches. But if you will, I lack the data on non-data-driven companies, which makes it hard to compare.
Daniel, if you look back over your career, what innovation or breakthrough with data do you feel most proud about that hit you?
It's funny, but perhaps the most fun one was a kind of data recycling. And this is work that I did while I was at Endeca, a company that I helped start. We were trying to do a social tagging, if you will, of a large corpus. And the insight that we had was that we could grab human-generated data and recycle it throughout the entire corpus, sidestepping a lot of complex machine learning. And then ultimately, we actually worked with ESPN on this. We were able to take this approach even using search logs. And my colleague, Monica Rigatti over at LinkedIn, has applied similar approaches to basically discover the training data that you would use for classification algorithms lying in plain sight. So I think the funnest things that I feel either I've done or colleagues of mine have done is to cheat by getting data that we didn't realize was around and plugging that into data-driven approaches.
Daniel, how often has your experiments which produce the data to make a decision been overruled, and why?
So I haven't experienced that per se, but the kinds of reasons that they would be overruled would be, there could be a few. One would be a dispute, if you will, over the objective function. So you might have some notion of what it means to improve accuracy. And it might be, for example, trade-offs between different types of errors. And when you set up your function, you say, look, this is an improvement based on that function. When people look, they're uncomfortable with it, and they decide that actually the metric was wrong. And this is difficult. But I can give an example, actually, that came from LinkedIn, where we had an improvement to the quality of our recommendations, but it was showing senior people recommendations for junior positions. And those senior people were complaining very loudly. And even though they were a small minority, it was an unacceptable problem. So we took, at the time, a hit in order to fix that mistake. And you could say that based on the measures we were using, what we did was irrational. But we knew, even if our measures didn't capture it correctly, that we could not afford the kind of embarrassing mistakes. And I think those are typically the cases where, if you will, anecdotes take precedence over data. You could argue that if you came up with the right measure, you'd capture that. But those are the only cases, at least in my experience, where data, if you will, has been overruled. And they've really come down to dispute over the metrics.
I just wanted to ask you a couple of questions. One is...
Oh, sorry. Okay. Sorry.
One was the first suggestion you made, the ask the right question.
Yeah.
Right? By definition, isn't that instinct? Because where do you get the right question from? You're not going to get it from more data. You're going to, anybody's ever presented to a CEO, right? Generally, you'll figure out that the CEOs don't make decisions by volumes of data. They have learned over the years through, call it instinct, call it experience, whatever, to ask the 2 or 3 right questions. And when they ask them, it is very clear to the person presenting, oh yeah, I got it wrong, or no, I'm right, right? And the question makes it clear. So getting the right question in itself is not that instinct. That's one. The other one is the scientific theory. Right? It is generally bounded by the current state of knowledge. So what you propose, I think, makes a lot of sense in terms of when you want to make incremental improvement. But when you're looking for big change, that generally comes from instinct. So when Newtonian physics did not contemplate or even imagine and would rule out the existence of quantum physics, right? For someone to then go find ways of saying how would that be explained, they had to first imagine it, not by data. They found data later on to validate it. I mean, same thing was true when we learned in high school science the theory of light, particle or wave, right? Both sides could prove with experiments that they were right. And it took somebody's instinct to figure out maybe it's both. How do you reconcile those kinds of big things by analysis?
I think you have a really good point, which perhaps I glossed over, which is that instinct does drive the exploration phase very often. I mean, that maybe it's often a very well-honed instinct as a result of lots of experimentation. But there's no question. I mean, look, if we didn't need something human in there, then we wouldn't be so concerned about hiring talented people to do this work. That talent, that essentially, at least as far as we know so far, that essentially human quality is still something that we need. And that, look, I've worked on anomaly detection and interestingness measures, but we haven't been able to overcome that. But the piece that's critical is the experimental validation. And even going back to the physics examples you use, look, it was scientific experiment that disproved the existence of the ether, right? If we go back to the Milken, is it Moore Milkinson? Morley, I'm sorry. Experiments that, we didn't like it necessarily any more than we necessarily liked discovering that we had to accept, a heliocentric view of the planets or any other sorts of scientific discoveries. I'm not going to claim that the process of scientific discovery is itself automated, that it's just a matter of throwing the data into some kind of a meat grinder and that comes out. No, for that that's why we have scientists who do that work, and why all of us have to have an instinct for that. But what is crucial, and not just for incremental improvements, but also for the bigger leaps, is that we always think of hypothesis validation. Imagine that you say, well, if I produce this product, then large amounts of people will buy it. Even at that simple basis, that's a hypothesis. You have to put that out there. You don't want to then say, when nobody does it, to say, oh, well, let me change that in retrospect. Let me fit the results to the test, which people do all the time, and then do lots of fun things. And I don't want to ruin anyone's career. If if it works for you, that's great. But that fundamental approach to hypothesis testing is crucial. It's easier with incremental improvements because you can almost follow a gradient. But it's no less valid even when you're making radical changes. And for what it's worth, even at LinkedIn, we've made radical interface changes, subjected people to them in bucket tests, and looked at them. We have to worry about novelty. There are all sorts of things we have to watch out for. But we use the same approaches in both cases.
Here's our final question.
Hi, I'm a big user of LinkedIn. I'm just wondering, what is the usage pattern? Are you measuring whether users are using LinkedIn more, less? What's the curve looking like?
Look, there's a lot of variety in our users. And obviously, the people who use LinkedIn, who we call outbound professionals, are some of our more aggressive users. Recruiters, people who are consultants, business development, sales, and so forth. Because those people, this is a tool that's vital to their daily work. What we found is that there are a variety of ways we can get people to be more interested in the site. We show them updates that are more interesting. If we send them aggregated information about their contacts that makes them realize there are interesting things going on in their network by showing news. And it's no coincidence that we're focusing on those products because we would like to see our general users approach a level of engagement comparable to our, the people who have been the earliest adopters of the site. So the movement is up, and I mean, you can look as we steadily climb up the charts on Alexa, Compete, what have you. But you can also just see it from the directions that our products take that, look, we still care about growth, but the biggest emphasis is on engagement, and in particular, everyday engagement.
Thank you so much.
Thank you. Happy to talk to folks later.